Welcome, and a very good morning to my panels, Mr. Hairul bin Bakri and Mr. T.S. Kairul Amri bin Kamaruzzaman. My name is Gautham Ratnam Sathasevam, and my metric number is B091810099, and I'm a student from Bmmv, currently in third year, second semester. Today, I'd like to do a presentation on my PSM report, which is titled Impact Test Simulation on Automotive Rim Using Finite Element Analysis. Before we start, I'd like to give a quick thank you to my supervisor, Dr. Muhammad Bazir bin Ali, for guiding me throughout this semester. Before we jump into our main topic, what is finite element analysis? Well, the finite element analysis is a simulation of any given physical phenomenon using the numerical technique called finite element method. Engineers use finite element analysis software to reduce the number of physical prototypes and experiments to optimize components in their design phase to develop products faster while saving on expenses. Nowadays, transportation is essential for everyone who needs to go from one location to another. The development of the wheel edge may be seen across the historical span, starting in early 1100 and till 800 BC, with just wooden wheels. As we all know, the pneumatic tires is developed by R.W. Ford, and it is one of the most important invention in auto industry. Although pneumatic tires provided various advantages, but there were few drawbacks. The impact test is a type of experiment that has a reasonable evaluation of a model in order to ensure that the safety of the passenger and the driver is protected from any threat. Crashworthiness is a phrase used to describe the ability of a structure to protect people inside it in the event of catastrophic accident. The purpose of the wheel rim control variable in this study is to determine what the example of a wheel rim means for stress and energy retention during impact tests. This is important because rim quality, for example, might affect the vehicle's instrumentation. Part mistakes during assembly, scrap portions of parts, and bad design are the key drivers. Next, moving on to problem statement. The goal must be to make the project manageable and to meet the needs of the client. Tire penetration factors such as fact pass out of nowhere victory due to pressing factor fluctuation, outrageous incompression temperature, and worn out are the most common car issues. This is important to know since in order to reduce the risk of the car collision caused by a wheel issue, the specific variables should be considered for a better result and a safer environment for the street users. Next, our objective. The objective for this research is to design a 3D model for alloy rim with different patterns to determine the energy absorbed with different pattern and orientation. Moving on to the scope of this project, the following are the project scope. Using SolidWorks 2021 software and create a model of a wheel rim based on Honda wheel rim design. Perform finite element analysis with HyperWorks software to investigate the project's model. Determine the amount of energy absorbed by the new wheel rim design with different pattern and orientation. To determine the state of the wheel rim under various conditions which will help with future research. For literature review, there are main three topics that is focused for this research. The main one is the wheel. Wheel is one of the most important components in the transportation business, as they are required by every transport vehicle. This fundamental component of the vehicle has an undeniable impact on the vehicle's determination, which can have a significant impact on vehicle's worth and capacity. Investigating the get together and adjusting the wheel plan, which reinforce the design and the steadiness, might help corporate the strategy. The presentation of the wheel must take into account of the safety of the passenger, which is associated with the weight of the vehicle itself, which serves as an optional burden and is subject to the enlistment of substitution restraint to the wheel edge, which cause dangerous plastic deformation of the wheel rim. Next is the weight of the rim. The heaviness of the wheel edge, which has a significant impact on the pushing factor acquiring by the wheel, in one of the variables that determine the vehicle's activity. These days, vehicles' wheel edges should be made of lightweight materials because they save a lot of money in terms of material costs and cost per kilometer. To minimize the heaviness of the wheel, some modifications have been made, one of which is the upgrade of the wheel edge by removing the unwanted area part and keeping the valuable portion of the wheel edge to retain the vehicle's attractiveness. By identifying the vital and undesirable location in the wheel edge, the purpose of this modification is to withstand the load applied to the wheel edge and equal circulate of the pressure given to the wheel. The model weight loss is also influenced by the number of spokes. Moving on is the material. The lightweight material is also capable of lowering the vehicle's mileage, improving its eco-friendliness. It can also reduce the vehicle's overall weight, allowing it to accelerate to its top speed in a short amount of time. Because of the vehicle will be exposed to the environment, which makes it easy for it to erode. The material used should be consumption resistant. Aluminum wheels have better execution than steel wheels, according to a limited component inquiry on the wheel edge certification. Aluminum wheels have the advantages of being lightweight, not corroding, and allowing more consistent steering, resulting in better fuel efficiency. The wheel development and assembly cost is so far less than steel wheel, and the aluminum wheels are significantly easier to project. Moving on to the methodology, this is my flowchart for this PSM1. From the design modification phase until the simulation phase, details information from each stage is explained and demonstrated in this full chapter. The project begins with literature review in which all relevant information and knowledge about the issue is gathered and analyzed so that the procedure may be carried out smoothly and properly. Moving on to rim design. As you can see here, this is the previous rim design done by Tan Yong Han for his previous research. So in this design, there are three types of design with different spokes, which has starting from the left, which has 4 spokes, and then moving on to 5 spokes, and then to 6 spokes. So these were the rims that used for this previous research simulations. And this is the current new design as per suggested in the objective. The rim design is based on the Honda's wheel rim design, which has 10 spokes for this simulation. And now for the striker design. The striker model is designed in SolidWorks software to meet the specifications of the wheel rim. The major goal of this study is to determine the energy absorbed during the impact loading, the surface of the area striker's loading site, and the result of the simulations, which is the element nodes, node location, and the total node number size. The striker model for this study is designed to have a V shape on its contact interaction with the wheel rim. The stress applied by the striker model can be concentrated directly on the tip of the wheel rim with this design model. With the current V-shaped striker model, the result produced after the simulation will be greatly improved for a better differentiation between both criteria. Moving on to the parameters. Well, these are the materials that are assigned to the created models. Steel is used for the striker and aluminum is used for wheel rim. And you can see the young modulus of the steel rim is 200 GPa and the density is 7.86 10 to the power of 3 kg per meter, and the Poisson ratio is 0.32. For aluminium, the young modulus used was GPa 70 GPa, density 2.7 times to the 10 power of 3, and the Poisson ratio is 0.33. Next is meshing. Meshing is an important step in simulation because it improves the simulation's output. The meshing process must be defined correctly, for example, so that it can be solved during the process. There is a wrapped element during the meshing process that will cause errors in the simulation. This is due to SolidWorks edit tools like chamfer and the rounded radius edges, which induce distorted elements. So as you can see the figure, this is the mesh elements of the parts for my striker and the wheel rim. Material definition. After meshing is complete, each instance material should be defined and added to the part's property. For the striker model, carbon steel was used as a material for the entire section, and aluminium was chosen for the wheel rim property. As you can see the both figures, these are the configurations for the striker model and the aluminum rim and their material definition. To wrap this all up, the whole study is that wheel rim has always been an important component in allowing a vehicle to operate normally on road. The objective of this study is to design 3D model for alloy rim with different patterns and also to determine the energy absorbed with different pattern and orientation. This is achieved by SolidWorks software and by creating a model of a wheel rim based on Honda wheel rim design. Then a finite element analysis is performed with the HyperWorks software to investigate the project's model. This is done to determine the amount of energy absorbed by the new wheel rim design with different patterns and orientation. Lastly, to determine the state of the wheel rim under various conditions which will help with future research. Thank you.